We are able to use determinants to find the area of a triangle. If a triangle in the coordinate plane has vertices at a1, b1, a2, b2, and a3, b3, then its area can be computed using this formula here, where the area is equal to plus or minus the determinant of this 3 by 3 matrix, with a1, b1 first and second, a2, b2, row 2, and a3, b3 in row 3, and the third column being ones, and they will always be ones. Now you may have noticed I said plus or minus at the front, and that does make a difference. How do you know which one? Well, you choose a sign that makes the area positive. So if you do all of this, the 1/2 times the determinant, and it comes out negative, put a negative in the front of the whole thing to make it positive. If it's positive, just keep it positive. I'll show you what I mean in just a second. So let's look at this triangle here. Now vertices are just the points of the triangle. So when I ask for the vertices, I just want to know what the order pairs are of the points. So the first one I have here is at 1, 2. Second one is at -1, 4. And third one here is at 3, 6. And so now I'm going to plug this into a matrix and find the determinant. Now you can do this by hand or you can do this in a calculator. I'm going to use a calculator because I think it's just a little bit easier. So here's my calculator, and I am going to go in and plug in my numbers into a matrix. So I'm going to do second matrix, go over to edit, and it is a 3 by 3 as shown in the formula up here. And then my points are 1, 2, and then 1 at the end, then -1, 4, 1 at the end, then 3, 6, and 1 at the end. So this is all well and good, all typed in nicely. So now I'm going to go back to second mode, get out of this, second matrix, and now I'm going to find the determinant of this matrix. So I choose the 3 by 3 for matrix A, and I get -12. Alright, well, if I get -12 or determinant, it makes things a little bit more difficult, but not much, and I'll show you what it means in just a second. So the area is equal to 1/2 times the determinant, which was -12. Now this is a problem. 1/2 times -12 is give me a -6. Can't have the area of a negative number. So instead of having a negative, I'm going to make this 1/2 also a negative to give me a positive when I multiply it. So -1/2 and -12 gives me a positive 6. So the area of this matrix is positive 6. Now, this is the order I had the vertices. What if I didn't put them in that order? What if I switched these two by chance? Well, let's see what happens. I'm going to go back to my calculator and second matrix. And let's just switch the first two. So instead of 1, 2, I have -1 and 4. And then for the next one I have 1 and 2. So I just switch those. Second mode to get out. Back to second matrix. Find the determinant. Oh, wrong button. Meant to hit number 1. And then back to second matrix. Number 1 again. And end up with a positive 12 this time, which is nice. Positive 12 means I don't have to worry about any negatives. So again, I would just go, and the area would just be 1/2 times 12, which is just 6. So whether it's positive or negative, not a big deal. If it ends up being a negative, just put a negative in front of the whole thing to make it positive. And if it's already positive, just keep it positive, and you'll get a correct answer.